In the 2-unit mathematics course, obviously, from what you've done in the junior course, we can guess that we're going to have a lot of work to do with algebra. And I'll probably say this in class, you've heard me say it in class, that if you don't like algebra, then it's probably not the course for you, because really it's vital that you understand the work we do in algebra. Because if you don't understand the algebra work and understand it extremely well, then you're going to struggle with the course, because the whole course is based around being able to do algebra and do it well without having to think about it. So, let's get back to basics. So, when we talk about the algebraic terminology, we've got a few ways to describe different things in algebra. So, the first one we talk about is an expression. Now, that's what an expression is, 3x plus 2. It's got no equal sign in it. So that's when we get an equal sign in it, we call it an equation. So there's a difference between an equation and an expression. Basically, we can write two things either as an expression or an equation. So we can, when we have x is equal to some number by itself, then we call that a solution, or it's a root of the equation. Basically, it's where it's been solved. And then we could have a situation here where we've got algebraic expressions on both sides and they're equal to each other. We could call that an equation. It's just written in a different way. Or we can call it an identity. And this one's true for all x. So they're the three things we need to be able to differentiate between expressions, equations, identities. There. So again, terminology we need to understand. Also, other things we need to understand is what happens when we get asked a question in algebra. What does it mean? So we've got a few things that will get asked. So the first one, simplify, basically means to make it more simple. Well, duh. But basically it means to collect any like terms we've got. So usually it's only used with expressions. You wouldn't have an equation and ask to simplify it. That doesn't happen. It's basically getting an algebraic expression and simplify it in its into the most simplest form. So expanding brackets and collecting like terms and getting all the x's together, getting the numbers together. So it's down and we don't have the same a like term there. Solve is used with equations. So we have solve an expression, solve an identity or an equation here in this case. So what we're trying to do is find the value of the variable. So we've got a variable in there. When we ask to solve, we want to find that value. We don't have a value to find when we simplify, but when we solve, we have a value to find. Evaluate means to calculate. So find the value of an expression of a formula given certain values. So we might have an expression, equation in terms of a formula, and to evaluate it means to find those values, find a certain value or find a particular value. Expand means to multiply out brackets. So when we've got expanding, then we've got a bracket there and we want to expand. And then generally we put it simplify as well. So we want to get rid of those brackets and when we expand. Factorize is to go the other way, is to express as a product. So as we've got it here, it's just an addition of two terms. But what we want to do is make it a product of two or more factors when we factorize. So we want to get back to a situation where we've got the brackets in there. So that's what we talk about when we ask questions with algebra. We want to do one of those things. So you'll see those in questions. You've got to understand and realize what the question wants you to do. So what can we do? The first thing is just basic operations with algebra. And hopefully remember this idea of like terms. Like terms are where we have the same exact algebraic terms there, expressions. So, and we can only add or subtract like terms. So when we look to add these ones up, 3a minus 2a would give us a. 4b plus 3b gives us 7b. A's are like terms, b's are like terms, but a's and b's are not like. So we cannot start getting down to one term. Don't be worried if you can't get down to one term. A lot of times people just try and get it down to one term. They think they've got to get down to one term. Like in this situation, one term. It doesn't have to. Doesn't have to. It can be two separate terms, and that's as simplified as we're going to get. We can't write that any more simply. So that's as simple as we can get there. With this one, well, xy is a like term, so we just collect them. 10 minus 1 gives us 9 plus 3, remembering our order of operations obviously. This one, 6x minus x gives us the 5x, minus y minus 5 gives us minus 6. Remember, the sign is the one that's in front, so we've got to make sure we're using the sign in front of it. Minus 3 minus 7 gives us the minus 10. 4 minus 9 gives us minus 5. We've got to be really careful with all our signs as we go through. We don't want to give away simple marks because of simple errors, and that it's really easy to do at times, especially in exams, but we've got to make sure we don't do that. X squared minus 5x minus 6x. Now, x squared and x are different terms. They're not like terms. X squared is x times x, so it's not the same as just x by itself. So when we do this, x squared would stay the same, but we've got minus 5 minus 6 gives us minus 11x. So that's by itself, so we can't do anything with that. That's as simplified as we're going to get. The same with here. 8a squared minus a squared would give us a 7a squared, and then minus 3a minus a gives us the minus 4. So be careful that you're identifying the like terms. Be careful that we are getting the signs correct as well. So when we multiply and divide algebraic terms, then we don't have to worry about like terms because everything's multiplication. So remember, this is minus 3 times a times minus 4 times a times minus 5 times a. So we multiply our numbers out. 3 times 4 times 5 gives us 60. Negative times a negative times a negative gives us a negative. A times a times a cubed. Remember our index laws. When we have a to the power of 1 times a to the power of 1 times a to the power of 1, we have a times a, which we can write as a cubed. So we're adding the powers there when we multiply it. So powers of like terms there in this case. The same algebra statement. Add the powers. So this one, m times the m squared times m cubed times m to the power of 4 gives us m to the power of 10. 1 plus 2 plus 3 plus 4. 2 times 3 times 4 gives us 24. So we're multiplying the numbers out and just collecting and multiplying our algebraic statements together, but adding the indices. So don't forget your index laws. So minus 9 times minus 2, positive 18. A cubed plus a plus the times a to the power of 4, add the powers. B squared times b, add the powers. C times c, add the powers. So be careful there. It's the same thing when we start to divide. We're subtracting the powers. Minus divided by minus gives us a positive. A cubed divided by a squared gives us a to the power of 1. B to the power of 4 divided by b is b cubed. So we have to write it that way. If we want to write our division, we can write it in that terms and do our division. The 6 and the 2 cancels to give us 3. B squared divided by b is b. C cubed divided by c is c. So that's all fine. We make sure we do it correctly. Now this time the 5 divided by 15. Well, that would give us 1/3. So we can write it all over 3. A to the power of 4 divided by a is a cubed. And d to the power of 5 divided by d is d to the power of 4. So we can write it either way. Whatever is more convenient for you. Whatever you feel more comfortable with. That's what you can go with. Minus 24 divided by 8. Minus 3. And then when the a 5 to minus the 2, because we're dividing. 9 minus the 3 gives us 6. C's got nothing to cancel with, so it just leaves it as C there. So be really careful. You've done all these before. This is something you've done since year 8 and year 9, and you were doing it in year 10 as well. So we've got to make sure we do it well all the time. Can't get these ones wrong. We've got to make sure that we get these right to make sure we pick up as many marks as possible.